student learners. Our lesson for today is about geometric sequence. The learning objectives for today are: you are going to define geometric sequence, find the common ratio, identify the types of geometric sequence, and determine the nth term of the geometric sequence. Consider the illustration here. You have this part of the pizza pie which is equivalent to 1/2. This portion is 1/6. This portion is 1/80. And this part is 1/54. You will understand later on how to get these fractions here as we tackle geometric sequence. Now, what do you mean by geometric sequence? It is a sequence formed by multiplication. The quotient between any two consecutive terms is the same, and it has a common ratio between any two consecutive terms, and it is constant and usually denoted by R, which is our constant multiplier. Now, to find the common ratio or the R, all we have to do is to divide the second term by the first term, or the third term by the second term, and so on. So this is the formula. R is equal to A sub n over A sub n minus 1. Supposing our n is 2, so 2 minus 1 is 1. So we have A sub 2 over A sub 1. So, for example, if we have 2, 4, 8, 16, 32. A sub 2 or the second term is 4. A sub 1 or the first term is 2. So 4 divided by 2 is 2. If we are going to take these two consecutive numbers, 8 and 4, so 8 divided by 4 is 2. Using these two consecutive numbers here, 16 and 8, 16 divided by 8 is 2. And using the last two terms, we have 32 divided by 16 is 2, meaning the common ratio is 2. Find the next three terms of each sequence. Number 1, 14, 18, 22, and 26. So what are the next three terms? The answers are 30, 34, and 38. Number 2, 4, 7, 10, and 13. What are the next three terms? The answers are 16, 19, and 22. Number 3, 2, 4, 8, and 16. What are the next three terms? Answers are 32, 64, and 128. Which of the following is a geometric sequence? And the answer is number 3. As you can see, 4 divided by 2 is equivalent to 2. 8 divided by 4, the ratio is 2. 16 divided by 8, the ratio is 2. So meaning there is a common ratio. That is why when we multiply 16 by the common ratio 2, the answer is 32 times 2, 64. 64 times 2, 128. So number 3 is considered as a geometric sequence. While number 1 and number 2, we cannot find a common ratio, but we can have a common difference. Because number 1 and 2 are both arithmetic sequences. Number 1, the common difference is 4, and number 2, the common difference is 3. Let us have 14, 18, 22, and 26. When we are going to divide 18 by 14, the answer is 9 over 7. 22 divided by 18 is 11 over 9. And 26 divided by 22 is 13 over 11. Meaning, this is not a geometric sequence because we do not have a common ratio. But we can consider this as an arithmetic sequence because we can find a common difference, which is 4. Next. Given 2, 4, 8, and 16. When we are going to divide 4 by 2, the answer is 2. 8 by 4 is 2. 16 divided by 8 is equal to 2. Therefore, we consider this as a geometric sequence because the common ratio is 2. Number 3, given 4, 7, 10, and 13. Dividing 7 by 4, the answer is 7 over 4. 10 divided by 7, it is equal to 10 over 7. 13 divided by 10, the answer is 13 over 10. So we cannot find a common ratio. Therefore, we consider this as not a geometric sequence. But this is an arithmetic sequence because we can have a common difference, which is 3. Next, determine whether each sequence is arithmetic or geometric. So, given the terms of the sequence 8, 10, 12, 14, 16, and so on, let us try to find out if there is a common difference. 10 minus 8 is 2. 12 minus 10 is 2. 14 minus 12 is 2. And 16 minus 14 is 2. Meaning, the common difference is 2. Therefore, we consider this as an arithmetic sequence. Next, given the terms of the sequence 8, 4, 2, 1, and 1/2, and so on. Let us try to find out if this is an arithmetic or a geometric sequence. Find first the common difference. 4 minus 8 equals negative 4. 2 minus 4 equals negative 2. 1 minus 2 equals negative 1. There is no common difference. So this is not an arithmetic sequence. Let us try to find out if we can have a common ratio. Second term divided by the first term, 4 over 8 equals 1/2. 2 over 4 equals 1/2. The fourth term over the third term is equal to 1/2. Fifth term over the fourth term, that is 1/2 over 1, is 1/2. Meaning, there is a common ratio which is 1/2. Therefore, we consider this as a geometric sequence. Do you have questions? If there is none, let's proceed. Let us have the types of geometric sequence. The first one is finite geometric sequence. The second is infinite geometric sequence. Now, what is a finite geometric sequence? It is a geometric sequence with a definite number of terms, meaning the sequence is with a last term. For examples, number 1, given 1, 5, 25, 125, 625. So this is a geometric sequence because there is a common ratio. And what is the common ratio? It is 5. And it has a last term which is 625. So we have a definite number of terms. Number 2, 32, 16, 8, 4, and 2. This is a decreasing geometric sequence. It has a last term which is 2. So meaning the number of terms is definite. And this is geometric since it has a common ratio which is equivalent to 1/2. Next, number 3, you are given 1, 10, 100, 1,000, 10,000. It has a definite number of terms and the last term is 10,000. And this is geometric because there is a common ratio which is equivalent to 10. Next, let us have the infinite geometric sequence. An infinite geometric sequence is a geometric sequence with indefinite number of terms, meaning without a last term. And there is an indicator which is called as an ellipsis. The 3 dots there. Examples, you are given 80, 40, 20, 10, 5, and so on. So we have the ellipsis. So meaning no last term. So this is infinite. Number 2, 0.8, 1.6, 3.2, 6.4, 12.8, and so on. So another example of infinite geometric sequence. And number 3, you have 1/2, 1/6, 1/18, 1/54, 1/162, and so on. If you notice, the first 4 fractions are the fractions represented by the parts of the pizza pie. And how will you get 1/6? That is 1/2 times 1/3. So 1/6. 1/6 times 1/3 is 1/18 and so on. So that is why the example given about the partition of the pizza pie is an example of a geometric sequence. Next, let us find the common ratio and the next 3 terms of each geometric sequence. Given 6, 12, 24, 48, and so on. Find out first if there is a common ratio. So, using the second term over the first term, we have 12 over 6 equals 2. Third term over the second term, 24 over 12 equals 2. A sub 4 over A sub 3 equals 48 over 24, which is equal to 2. Therefore, there is a common ratio equivalent to 2. Let's continue. Since the ratio is equal to 2, then we can find the next 3 terms. So to have the 5th term of the sequence, all we have to do is to multiply the current term, which is 48, by the common ratio 2, which is equal to 96. And 96 now becomes the current term. So 96 times 2 equals 192. And for the 7th term, 192 times 2 is equal to 384. Therefore, The next three terms are 96, 192, and 384. Next example, you have 1 over 2,500, negative 1 over 500, 1 over 100, and negative 1 over 20, and so on. We have to find out if there is a common ratio. So the second term over the first term. The second term is negative 1 over 500 over the first term, which is 1 over 2,500, which is equal to negative 1 over 500 times the reciprocal of this 2,500 over 1. If you would like to multiply 1 times 2,500, that is 2,500. Then 500 times 1 is 500. So 2,500 over 500 is negative 5 because we have a negative here. Or if you would like to cancel 500, it will still give you a negative 5. Next. For the third term over the second term, it will still give you negative 5. Cancel 100, so it will give you negative 5. Fourth term over the third term, it will still give you negative 5. 100 divided by 20 is 5 with a negative, so negative 5. Or if you would like to cancel 20, still it will give you negative 5. Therefore, the common ratio is negative 5. And since the common ratio is negative 5, to get the next three terms, the fifth term can be taken by multiplying the current term, which is negative 1 over 20 times the ratio negative 5, which is equal to 1/4. Then, for a sub 6, you have 1/4 times negative 5, which is equivalent to negative 5/4. And for the seventh term, we have negative 5 over 4 times negative 5, which is equivalent to 25 over 4. Therefore, the next three terms are 1/4, negative 5/4, and 25 over 4. Do you have questions? If there is none, let's proceed. In general, a geometric sequence is of the form a sub 1, a sub 1 times r, a sub 1 times r squared, a sub 1 times r cubed, and so on until you will reach a sub 1 times r raised to n minus 1, where a sub 1 is the first term, n is the number of terms, and r is the common ratio. Now, finding the nth term of a geometric sequence, we can use a formula. And the formula is a sub n is equal to a sub 1 times r raised to the exponent n minus 1, which is the last term of the previous slide, where a sub n is the nth term, a sub 1 is the first term, and the number of terms, and r is the common ratio. Let us have an example. Find the fifth term of the sequence 3, 18, 108, and so on. So find out if there is a common ratio. Second term over the first term, so 18 over 3 is equal to 6. Third term over the second term is equal to 108 over 18 is equal to 6, meaning the ratio is 6. And using the same given 3, 18, 108, the first term is 3. The ratio is 6. And since we are asked to look for the fifth term, so it will be represented by a sub 5. And n is equal to 5. This is the formula to find the nth term of a geometric sequence. Then we are looking for the fifth term is equal to substitute 3 to a sub 1, substitute 6 to r, substitute 5 to n, then minus 1. And a sub 5 is equal to 3, simplify, 5 minus 1 is equal to 4. And a sub 5 is equal to 3, 6 raised to exponent 4 is equivalent to 1,296. And multiply 3 by 1,296, the answer is 3,888. Therefore, the fifth term is 3,888. Next example, find the 10th term of a geometric sequence if the first term, or a sub 1, is equal to 6 and the common ratio is 5. The first term is 6, r is 5, n is 10 because we are looking for the 10th term, which is represented by a sub 10. So using the formula, a sub n is equal to a sub 1 times r raised to exponent n minus 1. So a sub 10 is equal to, first term is 6, r is 5, raised to exponent 10 minus 1. So a sub 10 is equal to 6 times 5 raised to exponent 9, and 5 exponent 9 is equal to 1,953,125. And a sub 10 is equal to 11,718,750. Therefore, the 10th term is 11,718,750. Next, example number 3. During an initial phase of an outbreak of measles, the number of infections can grow geometrically. If there were 4, 8, 16, and so on the first 3 days of an outbreak of measles, how many will be infected on the 6th day? So, solution, find out if there is a common ratio. First term is 4, the second term is 8. So 8 over 4 is equal to 2. Then 16 over 8 is equal to 2. So the common ratio is 2. Next, let's continue the solution of example number 3. A sub 1 is equal to 4, r is equal to 2, n is equal to 6, and the missing is a sub 6. Using the formula a sub n is equal to a sub 1 times r raised to exponent n minus 1. So, all you have to do is to substitute 6 to n, then 4 to a sub 1, times the quantity 2, which is the value of the ratio, raised to exponent 6, which is the value of n, minus 1. And a sub 6 is equal to 4 times 2 to the exponent of 5. 6 minus 1 is 5. And a sub 6 is equal to 128 because 2 exponent 5 is 32. Times 4, it will give us 128. Therefore, there will be 128 people infected with measles on the 6th day. Do you have questions? There is none. Let's proceed. Let us find the common ratio of the geometric sequence using the formula a sub n is equal to a sub 1 times r raised to exponent n minus 1. Or, applying formula transformation, if you're going to divide this by a sub 1, divide also the other side by a sub 1, then we can have r raised to exponent n minus 1 equals a sub n over a sub 1. Let us have example number 1. Find the common ratio. So represented by R, where a sub 1 is equal to 2, n is equal to 5, and a sub 5 is equal to 32. So using the first formula, a sub 5, which is our last term, represented by a sub n, that is 32, is equal to the first term is 2 times the quantity r is missing, n is 5 minus 1. 32 is equal to 2, 5 minus 1 is 4. 32 is equal to 2 times r raised to exponent 4. And divide by 2, divide the other side by 2, then you will have 32 divided by 2 is 16, cancel 2, then we have r exponent 4. Then applying the symmetric property of equality, we can interchange the position. R exponent 4 is equal to 16. Extract the fourth root of r raised to exponent 4. Extract also the fourth root of 16. So r is equal to 2. The fourth root of 16 is 2. Thus, the common ratio is 2. Or, if you will use the other formula, which is r raised to exponent n minus 1 is equal to a sub n over a sub 1. So, r raised to exponent 5, so n is 5 minus 1, then a sub n, the last term is 32 over the first term, which is 2. 5 minus 1 is 4. 32 divided by 2 is 16. Then extract the fourth root to solve for the value of r. So the fourth root of 16 is 2. If you would like to use this formula in solving for r, you can do it. Or if you would like to use this formula, you can also use this. Next example. Find the common ratio given the first term and the last term. So still using the first formula, you will have 648 as a sub 4 or the last term is equal to 3, which is our first term, and r is missing, n is 4, then minus 1. 648 is equal to 3 times r cubed. 4 minus 1 is 3. Then multiplying 3 times r cubed is equivalent to 3r cubed. Then divide by 3, divide by 3, cancel 3. So 648 over 3 is 216. Then we also have r cubed here. Then applying the symmetric property of equality, we can have r cubed is equal to 216. And r is equal to the cube root of 216. Extract the cube root of r cubed, the answer is r. And the cube root of 216 is equal to 6. Thus, the common ratio is 6. Or, if you would like to use the second formula, r raised to n minus 1 is equal to a sub n over a sub 1. Then, n is 4 minus 1, and a sub n, which is a sub 4, and a sub n is 648 over 3, and 4 minus 1 is 3, so r cubed is equal to 648 over 3 is 216. Extract the cube root, extract the cube root, then the cube root of 216 is equal to 6. There, you will have the same answer. So it's up to you what formula are you going to use in order to get the common ratio given the first term, the number of terms, and the last term. Do you have questions? If there is none, then let's recap. So the three formulas we have for the geometric sequence, you will have a sub n is equal to a sub 1 times r raised to exponent n minus 1 if you want to solve for the nth term. And then for the common ratio, using the two consecutive terms, you can find the common ratio with this formula. R is equal to a sub n over a sub n minus 1. And another formula in finding the common ratio given the first term, the n and the a sub n, you can have r raised to exponent n minus 1 equals a sub n over a sub 1, or you can use the original formula. Do you have questions? If there is none, then see you next time. Bye!